The last group of the diapsids that we need to recognize were the flying reptiles. Now, I want to hasten, these were not dinosaurs. These are flying reptiles. And they, again, were radiating off of the main line that was going towards dinosaurs, but they are not dinosaurs. They branched off and radiated in a slightly different direction. So the flying reptiles, the flying diapsids, we call them pterosaurs. And the pterosaurs were the first vertebrates to be able to access the air environment. So what were they composed of? What made them different? Well, as you can see in some of these diagrams and some of the reconstructed sketches of the pterosaurs did something that was just remarkable. They had a limb that had finger projections off of them, and they had 5 fingers that came off. But one of the fingers ended up growing meters in length. So the little finger on both hands on the pterosaur grew to be longer than the entire body of the pterosaur. So as you can see in the diagram, you can see the fingers coming off, and then that last little finger, it extends out and makes a very long spine that runs out and away from the hand. Now what the pterosaurs did was, through evolutionary selection, they ended up stretching a skin membrane between the little finger and the body. So that skin membrane, the wing if you will, it was attached across the entire length of the little finger and then attached across the entire length of the body. So it was a very different kind of flying apparatus from a modern day bird. So I just want to make it clear, the birds evolved from the dinosaurs, and the pterosaurs are a flying reptile that emerged prior to and were not dinosaurs. So the pterosaurs had a unique strategy for flight. And another thing about the pterosaurs is that they ended up developing, and we think that this has to do with aerodynamics as well as the need to make their skeleton as light as possible, because flight takes a lot of energy, is that their heads became very well ornamented, and the bones within the head became hollow. And so as you can see from some of the reconstructions in these diagrams, is the pterosaurs ended up with an extremely well what we call ornamented skull. The skull had many shapes and projections, became elongated, in some places flattened, and there was a great radiation in the diversity of the different types of species of these pterosaurs. So the pterodactyls were very good at accessing the air environment, and they diversified greatly in that process. Now, unfortunately, the pterosaurs were one of the diapsid lineages that went extinct at the Cretaceous Tertiary meteor impact event at 65.5 million. So that meteor event took out the dinosaurs, took out the pterosaurs, took out the plesiosaurs, took out the ichthyosaurs. Only one small lineage of dinosaurs survived across the Cretaceous Tertiary boundary, and that went extinct very rapidly right afterwards. So virtually every one of the great lineages of the diapsids went extinct, except for the crocodiles, and except for a few small representatives of some of the other reptiles that made it through. And of course, the anapsids also survived, the lineage of the reptiles that had no hole in the skull behind the eye socket. So the meteor impacts visiting the Earth, they were somewhat fickle. They destroyed and caused extinction in a lot of different organisms, but some of them eked through each of these events. And then as the events happened, then the ones that made it through were the ones who had the chance to radiate and diversify and fill the new empty ecosystem that had been made empty by the catastrophe of the meteor impacts. So this is the history of the Mesozoic age of the diapsid reptiles. And this set the stage then for the manifestation of diapsids to then rule the planet and make the Cretaceous truly the age of the dinosaurs.